All right, so we said we'd find or show another method for example 21. And just a reminder of the question, it's consider the graph of y equals tan of 2x minus 3, determine the equation of the first two positive asymptotes. This first method is what we went through in the previous little bit. Another way of thinking of this, I guess, we know that asymptotes occur where we have an undefined value. So with method 2, this second method I'm going to show you, the way we're thinking of it is, I guess, where is tan of 2x minus 3 undefined? And well, what we can say there is that we know that if you think about tan theta, well, tan theta is undefined, excuse my handwriting, at, and let's go to the unit circle here to help us out. Sorry, I'm just going to write this where you can actually see it. So we know that we have cos theta and sine theta as the x and y axis of our unit circle, and if tan theta is equal to sine theta on cos theta, then tan is going to be undefined whenever cos theta equals 0. And so around the unit circle, where x equals 0 is up here at pi on 2, and down here at negative pi on 2 or 3 pi on 2, depending on which way we go from 0. So tan theta is undefined at theta equals pi on 2 or negative pi on 2 or 3 pi on 2, and so on. So in our question, theta, the angle, is 2x minus 3. So therefore it's undefined when 2x minus 3 is equal to, well, let's start with the most negative one, the smallest one, negative pi on 2. And if 2x minus 3 equals negative pi on 2, then 2x would equal negative pi on 2 plus 3. And dividing both parts by 2 would give us negative pi on 4 plus 3 on 2. Now, that's, negative pi on 4 is about negative 3/4. We went through this in the previous question as well. That's about negative 0.75, very approximately, plus 1.5. So that's going to be a positive answer. All right. So this is potentially a solution here. Remember that we're looking for the first two positive asymptotes, or the first two positive undefined values in terms of x. The other one that we had, or another one that we had, 2x minus 3 equals positive pi on 2, right? So we're just letting the angle equal the value that we know the angle will give us an undefined value for tan. So 2x equals pi on 2 plus 3. X will equal, dividing both sides by 2, pi on 4 plus 3 on 2. We know that's going to be a positive number. Okay. I guess what we want to make sure is that these two, which we just said are positive numbers, are actually the first two positive numbers. So what we could do is say, okay, let's go a little bit sort of backwards on our unit circle. We already used this value here at negative pi on 2, but if we kept going in the negative direction, this would be negative 3 pi on 2. So from 0, negative 3 pi on 2. So let's just check and make sure if we say that the angle can equal negative 3 pi on 2, let's just see if this gives us a positive value for x or not. So take the 3 over, divide both sides by 2. Right, so as we said before, we know that pi is about 3, so this would be, roughly 3 times 3, which is 9, 9 over 4, so that's 2 point something, so negative 2 point something plus 1.5. This is going to be a negative answer, as we saw in the other method. So that's negative, we're not going to use that. These two are our first two positive values. All right, so in questions like that where maybe you can see two reasonable methods for working something out, obviously in a SAC or an exam you pick the one that makes the most sense, but sometimes it's useful to see two different methods, just in case for certain questions one method is much easier than the other. And it's also useful to remember that whenever we're thinking about asymptotes on graphs, those are values where something's undefined, right? Values of x where we don't have a defined y value, that will always give you a vertical asymptote on a graph. And so the second method there might be a useful reminder of where asymptotes actually come from as well.